Let's do slightly larger example that kind of combines the topics that we've talked about in the previous videos. So go ahead and pause, write down the example, and then we'll talk about it. All right, so in this case, we've got a $500,000 mortgage. We're going to pay it for 30 years, but we're going to make monthly payments. We're given a nominal annual rate of 8.4% compounded monthly, and we want to find a bunch of different things: the monthly payment, the total principal and interest paid over the life of the mortgage, the balance after the 5 years, and then the total principal and interest over the first 5 years. Since we've got a 30-year monthly payment mortgage, the total number of payments we're going to make is $360. Since the period that we're paying, or the period that we're making each payment during, is a month, we need to convert this nominal rate compounded monthly to a monthly rate. So to do that, we take the I-12 over 12 to get 0.7% in this case. We calculate our loan amount as the present value of annuities. So the given loan amount is $500,000. We don't know the payment. We can calculate this value on the calculator and get 3809.19, solving for the monthly payment. Nice calculator active problem there. All right, for the second part, the total principal that we pay over the life of the mortgage is paying back the $500,000. So the total principal paid is just simply the $500,000. So as the interest paid over the entire mortgage, it's a little bit more interesting problem, because certainly we've paid back more than just that $500,000, and what we've paid over the $500,000 must be interest. So the total amount you pay is the payment amount times the total number of payments. So that 3809.19, we're going to multiply it by the 360, subtract off the principal amount that we paid back, and we note that the interest paid back is $871,308.40. Okay. Shifting over to the balance after 5 years. We can do this from a prospective or the retrospective method. Prospective, remember again, that's looking forward. That's the present value at the time we're interested in of the remaining payments. We're interested at time 60. After 60 months means that there are 300 payments still remaining. So when we look at the prospective method, we do the present value of this annuity, the present value of the remaining payments, get $477,043.59. From retrospective, remember that's looking back. That's the accumulated value of everything up until the time that we're interested in. The accumulated value at time 60, after 60 months of the loan balance, is this 1.007 to the 60th times the 500,000. We also need to subtract off the future value, the accumulated value of the payments that we've already made. That's where this S angle 60 is coming in. That's accumulated value. Calculating all of this, we get a similar value, obviously, to the prospective method. The pennies are off a little bit, but that's because, again, we've rounded our payment to start with to 2 decimal places, so we've got some rounding error that's been compounded a few times. Remember, again, though, on exam FM, you're not going to have 2 consecutive answers that are that close together. That 477,043 matching is going to be enough for you to be able to select what the answer is. All right. How do we figure out the total principal paid over the first 5 years? Well, in that case, we just need to worry about what has been the change in the balance. Whatever the change in the balance is how much principal has been paid down. So we know that our balance after 5 years is this $477,043.59. I just picked the prospective balance out. Subtracted from the initial balance, which is $500,000, gives us that principal paid is $22,956.41. If this is the total principal paid, we can figure out how much total we paid over the first 5 years. That's this 3809.19 times 60, much like what we did for the total amount we paid over the whole life of the mortgage. Subtract off how much of that has been paying down the principal, and we notice that in 5 years we've paid $205,594.99 in interest.